Hello everyone, my name is Arthur Kaminsky, and I will present our paper named PyStuBs, Characterizing Single-Statement Bugs in Popular Open-Source Python Projects. Throughout their careers, developers have to deal with bugs from varying levels of complexity. While some of these bugs can take a long time to be fixed and end up spending precious development time, single-statement bugs, also known as stubs, can harm developer productivity by frequently interrupting their workflow. Identifying and characterizing these stubs may therefore help developers in understanding and identifying them sooner, reducing the amount of time they have to spend debugging their code. However, there is still little knowledge about how these stubs occur in different programming environments. Previous research has analyzed the occurrence of stubs in the context of 1,000 Java Maven projects. In our study, we aim to expand the previous work by characterizing stubs occurring in a different scenario, namely, projects that use the Python programming language. We started by selecting the 1,000 open-source Python projects with the largest number of stars on GitHub, using GitHub's Search API. With the list of repositories at hand, we collected their data, which included both files and commits, using World of Code, an infrastructure for mining open-source software and their version control data. To identify stub patterns, we selected the Python files modified by bug-fixing commits that presented only single-statement changes. We extracted abstract syntax trees from each file before and after the changes occurred, and programmatically compared those trees to identify the first node in which they diverged. We manually classified the diverging nodes into stub patterns. As a result of that process, we identified 20 different stub patterns, being 7 of them new patterns that were not previously defined. We could identify 13 of the original 16 bug patterns characterized for Java Maven projects. The remaining 3 patterns cannot occur in Python due to syntax differences between the two languages. We also found that many stubs are related to Python's dynamic typing system. For example, Python allows developers to easily change the type of a variable without changing its declaration, by changing the values assigned to it or by adding a function around it. We compiled our results in a dataset containing 73,000 instances of the stub patterns we found in the studied Python projects. This dataset is publicly available on Zenodo. More detailed descriptions of our results and the dataset can be found in our paper. Thank you for watching.